am Hussnain Ali from Bagh School. Welcome to online Bagh School learning. I'm grade 13 A-levels teacher. This is a video related to question number 5 of mock 2 paper 4. In this video, we will be discussing the question number 5. The question number 5 A part was that state the functional group positively identified by the following. Here, the first one was bromine. The bromine, as we know, that it is used to identify the carbon-carbon double bond. So the answers are given at the bottom of the slide. So bromine is a reagent that is used to identify carbon-to-carbon double bond, as the compound that contain the carbon-to-carbon double bond decolorizes the bromine water. While for the second part, sodium is a reagent that is used to identify OH group, whether it is present in an alcohol or it is present in a carboxylic acid. The third part was relevant to iodoform testing. This is an iodoform reagent. It is used to identify the groups, the ketonic group or the aldehydic group that contains a carbonyl with a CH3 and an alcoholic carbon that contains an OH group along with H and the CH3 group. The CH3 group here is shown for the alcoholic part. This group is to be identified by iodoform test, and for the carbonyls, CH3C double bond O is the group that is identified by iodoform reaction, as yellow PPT are formed in the form of iodoform that are CHI3. So students, you can go through the notes and see what iodoform reaction is. Keep in mind that the only aldehyde that gives the iodoform reaction is ethanol. Otherwise, the carbonyls that give this reaction are only ketones that contains a carbonyl carbon attached with the CH3 group. The fourth part was the reagent that is used to identify for the identification purposes for the carbonyls. It is known as 2,4-DNPH or 2,4-dinitrophenylhydrazine. So the fourth part answer was that this reagent 2,4-dinitrophenylhydrazine was used to identify the carbonyls, aldehydes or ketones. Coming back to the further part, that was compound G has the molecular formula C7H14O. Treating G with hot concentrated acidified KMnO4 produces two compounds H and J. The four reagents in A were used to test these three compounds, and the results are shown in the table below. So he has given us a compound that is G, the molecular formula of C7H14O. When it is treated with hot acidified KMnO4, it produces H and J. Their molecular formulas are given. We have to use the above reagents in the A part to identify what H is, what J is, and what G is. So if you would be going through the reagents and the tests that are given by them, you can write the subparts of the molecule that are present by identification tests. Here the compound G gives a test with bromine. It decolorizes the bromine water. It means that the compound G contains a carbon-to-carbon double bond. While the G compound also gives a positive test with sodium reagent, it means it fizzes. So it means that the G compound also contains an OH group. No further reactions are given with iodoform and 2,4-DNPH by G. For the compound H, no reaction was given with bromine, no reaction was given with sodium. The reaction was given by the H with iodoform. It means iodoform reagent gave the yellow precipitate with H. It means that the H compound basically gives the groups that are identified by iodoform testing. While the H compound also gave a test with 2,4-DNPH, it gave orange precipitates. It means that the H compound also contains a carbonyl group. So as the H is concerned, its molecular formula is C4H8O. So it is a ketone, obviously, because the only aldehyde that gives the iodoform test is known as ethanol. So we are only left with a ketonic group that the H would be having. And the condition here for the H is that the carbonyl should be attached with the CH3, while the rest of the carbons are attached on the left side. So this is the structure of H, which you would be able to identify with the help of these results. While for the compound J, it gave no reaction with bromine because it doesn't contain any carbon to carbon double bond. It fizzes with sodium, it means it contains an OH group. It gave yellow precipitate with iodoform, which means that it is positive for iodoform reaction. It gave 2,4 test with 2,4 D and pH. It means that the J compound also contains a carbonyl carbon. Thus, the J compound has basically three functional groups, that are OH group, an iodoform group, and a carbonyl group. So combination of the molecular formula of J is C3H4O3. It means that it should be a ketone as relevant to the carbonyls, and that ketone should have a CH3 group attached with it. Here I have shown the molecular the structural formula the skeletal formula of J. Here CH3 group is attached with carbonyl. It is a carbonyl which has a CH3 group. It would give a positive test with the iodoform, while other oxygens and carbons are to be filled in. So by the help of the molecular formula, we are able to identify that the other carbon and oxygens that are to be filled or that are to be attached within the J structure is basically a carboxylic acid part. So the carboxylic acid part is basically giving the reaction with sodium and it fizzes. These are the structures of H and J at the bottom of the slide, and this is the solution. You can go through your notes also to relate how these structures are found. Now in the C part, he was asking compound G exists as two isomers, draw the structural formula of each of two isomers and state the type of stereoisomerism involved. So C gives two isomers. As we can see that in the G compound, the molecular formula was C7H14O. It gave a reaction with bromine. It contains a carbon-carbon double bond. So this compound should give a geometric isomerism, while it also contains an OH group. So in C, the geometric isomers that are to be formed of G are shown here. Here the CH3 group is attached with carbon that contains a double bond, and the other CH3 group is this one. These two CH3 groups are in cis form, while the other chains are to be attached along with an OH group within the molecule. So you can form cis trans isomer with the relevance of methyl groups, or you can form a cis trans isomers with the relevance of H. There could be another structure of G. You should try that structure also and send it to me on WhatsApp so that I can refer whether you have written the right answer or not. So these are the two cis trans isomers that are formed by G. So if you would be drawing these two structures, you are able to get 3 marks. Thank you for your kind listening. Allah Hafiz.